been not the friendliest of places for the greater part of its existence. Let's cast our mind back to the Archean Eon, the earliest time when life was known to be around. It began 4 billion years ago and continued for approximately 1.5 billion years. The early Earth had just gone through the second heavy bombardment. Several thousand tons of rocky debris from the formation of the solar system was hurled to the planet, smashing the thin basalt crust that had just formed on the surface of molten magma. Even after this ordeal, the young Earth cooled off again and gained its first lithosphere. Just a billion years later, it became home to the very first living organisms. The Earth of that period had a comparatively smooth surface. Tectonic plates, that is, rocky bodies that create high mountain ridges on collision, were simply non-existent at that early time. There was no diversity in rocks on the early Earth either. Banks of ores and rocks were in the first stages of formation. Most of the Earth's crust was made up of basalt, a rock formed from magma, and in essence, it is solid lava. There was almost no oxygen in the atmosphere in the Archean. The concentration of nitrogen was considerably smaller than it is now. The Earth was shrouded in a dense mixture of water vapor and carbon dioxide, with a high percentage of oxides of sulfur, phosphorus, and other active chemical elements. The sun was much dimmer then than it is now. According to some estimates, its luminosity was even 30% less than that of today. That is why our planet was quite a murky place. The moon still used to find itself in close proximity to it, so a day lasted just around 10 hours. As for tidal waves, they reached up from several dozen to 300 meters. As the Earth gradually cooled off, water in the atmosphere condensed and poured down in torrential rains. At first, it accumulated in small bodies of water in lowlands. This water was sour, salty, and extremely hot, up to a boiling point in some places. Its composition resembled that of today's geysers. Paradoxically, this seemingly harsh environment proved to be the cradle for primitive life forms that originated and evolved there. It goes without saying that first organisms were anaerobic. Instead of breathing oxygen as we do, which was non-existent in the atmosphere at the time, first living organisms relied on other sources of energy. Archean organisms were not yet able to swim. In order to survive, they needed a substrate. That is why the biosphere of the time was a thin, slimy film of not 1 millimeter width on the bottom of a sour and hot ocean in its coastal area. The maximal depth the biosphere reached down was up to 20 meters, as the dense atmosphere did not allow sun rays to penetrate deeper. The mouths of underwater volcanoes offered habitats to bacteria that were chemotrophs. These bacteria didn't need light and fed on other energy sources, relying on chemical reactions between sulfur compounds and iron. The Earth was cooling off, sea levels rose, the atmosphere became more rarefied, and the sun gradually grew in size. The coastal area favorable for life was also gradually expanding, and by the end of the Archean Eon, the biosphere was confined to a thin stripe along the coasts and also oases, as it were, on the sea bottom near active volcanoes. Meanwhile, all the land, rivers, and most of the open ocean were still completely devoid of life. If an explorer were to visit the Earth of that period, stromatolites would be the only evidence of life seen with the naked eye. These sedimentary limestone formations were created by primordial microorganisms and may reach up to several meters in height. There was another problem in that age. The amounts of reagents were insufficient, and that greatly impeded the evolution of life. Evolution hadn't yet produced scavengers, organisms feeding on dead flesh. Thus, under the influence of gravity and sea currents, dead creatures accumulated in cavities on the sea floor. Hundreds of millions of years later, these accumulations were processed by nature into what is now oil fields. Around 3.5 billion years ago, there emerged creatures that were to change the Earth beyond recognition. some bacteria got the hang of photosynthesis involving oxygen production. A billion years later, on the border between the Archean and the Proterozoic eons, their evolution brought about the most global extinction in the history of the planet. It is known as the oxygen catastrophe, to name but one term. I have spoken in more detail about it in an earlier video. It is hardly possible to estimate the scale of that event, as an overwhelming majority of the creatures didn't get preserved as fossils. Practically all the diversity of anaerobic life forms that had taken a billion years to evolve vanished off the face of the Earth. The ancient Earth's atmosphere was exceptionally rich in methane, a strong greenhouse gas. It robustly oxidizes, producing carbon dioxide and water during process. With methane's concentration in the atmosphere dropping, the temperature of the planet decreased as well. As a result of this process, there occurred the Huronian glaciation, the most large-scale ice age in the history of the Earth, which started 2.4 billion years ago and continued for as long as 300 million years. Diggings revealed that in some areas ice caps reached as far as the equator. The planet almost totally transformed into a ball of ice. It took the Earth 1.5 billion years to go all the way from boasting boiling lava fields to endless icy deserts. The Proterozoic eon lasted from 2.5 billion years to 440 million years ago. Life persevered in spite of the cold, and evolution, although thwarted, carried on. Nevertheless, land remained lifeless. Living organisms concentrated in the coastal area near the equator. And what was happening on the continents? Even though they weren't crawling with life yet, land was experiencing something different and interesting in its own way. Alongside the continents, banks of metal ores and new rocks were being formed. In the Proterozoic eon, areas of dry land alternately assumed different aspects and were endless glaciers and stone deserts at one time or another. It is hard to imagine, but just a measly 500 million years ago, the greater part of our planet appeared quite like a Martian desert. Luckily for all the dwellers of our planet, the sun was growing brighter and warmer. Eventually, the ice gave in. 542 million years ago, there began the Phanerozoic eon, which is the Greek for the eon of visible light. Was peculiar for periods of active evolution of different species interlaced with mass extinctions. I have told you about the major ones, but what was the Earth like in those days? At the beginning of the Paleozoic era, a greater part of land formed a giant supercontinent named Gondwana. Located in the southern hemisphere, it had elaborate terrain and covered over 100 million square kilometers. It was comprised of today's Africa, South America, Antarctica, Australia, the Indian Peninsula and some other areas. The smaller continents of the day, Laurentia, Baltica and Siberia, were situated near the equator. Apart from all that, there was a great number of smaller islands. Still, up until the Silurian period, which started approximately 444 million years ago, there weren't any life forms to speak of on all these expanses. Only some simple mosses and lichens were slowly establishing their dominance on land. It was only at the beginning of the Silurian period that first plants emerged in tidal areas and near rivers, and only in the tropical zone at that. Even in spite of the fact that sea species and plants became more diverse, marine life forms still concentrated near the coasts. The area populated incrementally expanded. To give you an example, the depth of the ocean at which photosynthesis was able to take place in the Devonian was just 50 meters, which is 10 times as little as it is now. In the same period, which began 420 million years ago and continued until 300 decomposers emerged, organisms decomposing dead flesh. As a result, there emerged organisms feeding on products of decomposition. For example, alongside scavenging bacteria, there could be found sea sponges at depths of up to 500 meters. The next period was the Carboniferous period. It continued from 358 to 299 million years ago. By the time it began, the greater part of the tropical zone was covered with tree ferns. Dense tropical forests did not grow as a mass. There were no organisms back then that would help wood decompose. That is why bulky trunks of trees didn't rot when they died, and didn't pass any nutrients to their descendants. They remained lying without decay, and the phosphorus in their bodies, so vital for plants, couldn't be extracted. Thus, with time, lush, sappy verdure gave way to enormous heaps of dead wood, covering enormous stretches of land. Later, they formed rich deposits of coal, which is still widely used by mankind in various industries. In areas other than the tropics, only fungi, mosses, and lichens could be found. They were not able to harden the upper layer of the earth by their roots, and as a result, rain easily washed it off, with rivers turning into muddy streams and lakes becoming putrid swamps. Dry areas became lifeless deserts. It was a time when fishes were vigorously evolving in the seas and rivers, although life hadn't yet ventured out into the open ocean. Algae hadn't learned to float yet, and so life was still confined to coastal areas. The Carboniferous period was followed by the Permian period. It began 299 and finished 252 million years ago. The first amphibians dared to start exploring land, and plants spread to conquer subtropics. The sea remained populated only in shallow waters close to the coasts. The Permian period finished with the most massive extinction event in the history of multicellular life. According to some estimates, up to 96% of marine species and 73% of land species died out. It is still not known what caused such a global mortality. The Triassic period of the Mesozoic era promptly made up for the lost time, bringing life to a new level during the process. For the first time in the history of the Earth, temperate latitudes could boast some woods. Another revolutionary event took place on the sea, where blue-green algae emerged, a type resembling their today's descendants. It was not vital for them to live in a substrate anymore, and so photosynthetic microorganisms quickly spread across the upper layer of the global ocean. Tempted by the food, fishes, mollusks, and arthropods followed it. Organic leftovers settled on the sea bottom. Thus, sea bottom dwellers were amply supplied with food as well. The global ocean was assuming an aspect close to today's. The Mesozoic era lasted from 250 to 66 million years ago. It is subdivided into three periods: the Triassic, the Jurassic, and the Cretaceous. This is when dinosaurs thrived, admittedly the most well-known prehistoric creatures that became subject of science fiction movies. The way these ages are depicted, we might get the idea that the Earth was covered with tropical forests from the poles to the equator. In fact, it is completely wrong. Indeed, forests reached northern latitudes, but only because the average temperature on the planet was much higher than it is now. Meanwhile, equatorial areas, on the contrary, suffered droughts. With the forests rapidly spreading across the entire Earth's surface, there were still lots of swamps and deserts around. The latter were not only scorching hot and dry, as we're used to picturing them, but also moderate, cool, and even humid. With no herbaceous plants around, soils could not attach themselves to rocky slopes. Only lichens are able to grow on barren rocks. Flowering plants became abundant only by the middle of the Cretaceous period, that is, around 100 million years ago. Interestingly, the first varieties were trees, and by the end of the period there emerged plants similar to today's herbs. Compared to a mighty oak or a giant sequoia, regular grass appears insignificant, but it is capable of something tree giants aren't. By mingling their tiny roots in the ground, they help form and strengthen the turf. This not only makes soil tougher and prevents it from getting washed off or eroding, but also takes care of getting rid of excess water by letting it evaporate and accumulating water when there is a lack of it. On emerging, herbaceous plants turned deserts into steppes, prairies and savannas, swamps into flood meadows, and permafrost areas into tundra and tundra steppe. By the time the Cretaceous period was coming to its end, the Earth had started to resemble the Earth of today. It was lacking just one important touch: mammals. This type of animals had been around for a long while, but the creatures were not very widespread until the end of the Mesozoic era. It is still not clear what caused dinosaurs to become extinct. A giant meteorite, global cooling, and other suggestions are listed among the supposed culprits. Either way, these giant saurians vanished, thus vacating a special niche for mammals. It took them 66 million years to evolve from tiny marsupials into majestic whales, dangerous tigers, tough camels, and amusing bats. Eventually, evolution produced a unique species, the only living creature capable of not only adapting to nature, but also changing it. The being that extracts coal formed of all those dead trees from millions of years ago to warm up one's dwelling. The creature exterminating other species for money and sport. The creature turning vast areas into wasteland for selfish motives. This is Homo sapiens.